Hey everyone, hey folks, how are you? Thank you for being here. Today I want to talk about how Docker has made UI testing accessible for everyone. I am Diego. I've been in tech for around 15 years, I think 17, 18, I don't remember exactly. And I started as a software developer who then moved to testing, and that made me what I am today. Someone who just does software engineering development, and I also love testing. Open source has been something that improved my career, and today I want to talk about the project that brought me closer to open source, and that project is called Docker Selenium. I am the lead of the open source program office at Sauce Labs. I am also one of the tech leads at the Selenium project. And if you want to reach out to me, that's my LinkedIn user, and that's also my user in what used to be called Twitter. So first of all, I want to share how Docker Selenium has improved and has helped the developer workflow through that set of examples. And to do that, I will explain a bit what are the most common dev challenges when developing web applications. And together with that, I want to go through the workflow that developers go when they are implementing these applications. And when I propose some solutions, some approaches to solve these challenges, I want to show how this makes an environment to be ready for the DevOps workflow. In the end, I just want to share some extra features that this project has, and we're going to wrap up with some thoughts and some questions from you all. To start, imagine that you are coding your web application and then you want to run tests before pushing your changes to the upstream Git repository. And when you notice you cannot continue working what you were doing because you see all these browsers popping up to your desktop. So you cannot work anymore until your test finish, right? Basically because all these browser windows are stealing your focus. And this means that your development workflow is being slowed down. The result of that is that you're going to end up changing context. And that's very, very hurtful for the normal developer workflow. So back in the day, when this project started, and this still happens, there were several workarounds for this situation. One was to use virtual machines that needed to be configured and maintained, and obviously keep them running all the whole time. And they usually consume lots of resources. They are not the ideal tool for this type of task. We also had, some years ago, headless browsers. Not the ones that we have today, but we had something like Phantom.js, which was a browser based on WebKit, the same as Safari, but this was headless. And today we still have something called HTML Unit, which is a Java browser that renders websites in memory. The thing with this type of browsers is that your customers that use your web application, they don't use these browsers, they use real browsers. Another option was to have a set of remote execution workflows. So you could have like a shared infrastructure, usually underpowered because testing usually gets the least amount of resources, and then you need to allow a remote host run a server that could actually run your tests. Basically, this meant that sometimes this could create bottlenecks if everyone was using the same shared infrastructure, and then you were getting some delays in your developer workflow. Sometimes, if you wanted to actually test the application that was running on your laptop, then you have to mess around with the network configuration to allow that remote machine access your local host. So it wasn't ideal, but those were the workarounds we had before. In general, the UA testing challenges can be spread in different parts. So the setup, then you also have the high costs, and you have the consistency of the environment. Back then, you had to deal with different things, like you have to have the right Chrome driver, the right Chrome version, so they could match between themselves. And in the end, this was very costly because when you were running tests, you could not use your machine for anything else, you just had to wait. So some people just decided to commit and push the changes and let the CI run this. But then you were switching to a different context, waiting for CI to finish, and then if something was failing, well, then you had to go back to that context, and this context switching is what really hurts ourselves. One interesting thing is that when someone was joining your team or the company, onboarding that person was very painful because they had to go through all the process of setting up all the environment for themselves. And in the end, there was no guarantee that what you were running locally, that setup was identical to the setup you had in the pipeline. So you could have different browser versions, you could have, like, for example, different viewports, and this could cause failures in the CI pipeline that you didn't see locally. So that's when Selenium meets Docker. I'm going to make a small parenthesis. I'm not going to assume that you know what Selenium is. Selenium is a project, it's an implementation of a W3C standard. So all the browser vendors, Mozilla, Apple, Microsoft, and Google, together with folks from open source, came together to decide how to automate browsers. So how a click works, how typing on a website works, all these things were decided in some meetings, and then they were implemented as a standard. And Selenium is one implementation from those for that standard. So this project started in around July 2014, and it started as a community effort. So people came together thinking about this challenge of doing proper UI testing when we were doing web development. And then the idea of this project is to enable developers and testers execute browser automation in a simple way. These Docker images pack Selenium Grid, the Chrome, Edge, and Firefox browsers, and again, another parenthesis, Selenium Grid is a way to execute tests in a remote way. So you could run your code locally, your test code locally, and direct all the commands to a remote instance that could be a shared infrastructure, something in the cloud, or Docker images, or the Docker containers that we have here. Some of the features these images have are like VNC, so you could actually see inside the container what's happening, and video recording. The videos I'm going to show you during this presentation and the, all the files, all the code are going to be in two different places. One is the demo repository I built, and the other one is where the actual project lives officially. So if you want to check it out later, those are the links. You should have a look at them. So when we use Docker Selenium, there is an improved experience. For example, imagine that you start developing your application locally, you make a change, and then you start the application locally with npm run dev. Then you go, you execute Docker Compose, you start Selenium Grid locally, and it has different browsers, like Chrome, Firefox, and Edge. You had a look at the web application, you see that, oh, this is a simple to-do app that whatever you type, it puts an image next to it, trying to make some visual context to it. And then this is the Selenium Grid with several worker nodes that offer you different types of browsers with different types of versions available for you for testing. All this is happening on your own machine. Then you decide to go and run your tests. So for this demo, what I'm doing here is I'm putting a sleep between commands so we can actually see something executing. Otherwise, the test would go really fast and we wouldn't see anything. So these tests are implemented in Python. I start running them, and then we check the local grid. We see how all the worker nodes get some sessions, and then this is your improved developer experience. You can actually use VNC to go and check what is happening inside the browser, pick how your test is doing, but you do this rarely, because usually you don't end up debugging tests, you just want to run them and you want to know if things work it out or not. So this is the way that we can improve this developer workflow, like having local infrastructure that doesn't block me from working in something else, but also it delays, it gives the responsibility to a different component, which is the Selenium Grid, to actually run this test for me. So if you wanted to start these containers, there are different ways. In this example I'm showing here, you can start this container to use either the Firefox browser, the Chrome browser, or the Edge browser. Small parenthesis again, Selenium Grid has different ways of working. One of them is the standalone, which is all-in-one, browsers and server in a single machine. Or you can also have a different mode, which is hub and different worker nodes. And this bash script, if you could call it like that, shows you how you can start the hub and then connect all the nodes to it. But for simplicity, you should always use something like Docker Compose. And the idea is that all of these different nodes connect to the hub, and the hub registers them. So basically, this is a way to tell everyone the hub is the entry node, the hub is the entry point, and these are the different capabilities I'm offering you for testing. A more straightforward way to do it is to use the Docker Desktop extension that was created by one of the Docker captains who is around here. So if we have more questions, we can go and talk to them. So now that we understand the challenges of this development workflow when developing web applications, let's see how we can improve this workflow. Ideally, we want to start services. We want to run tests, and we want to tear down everything with just a single command. I don't want to wait for things. I don't care about my browser, so the one that I have installed locally. I don't want to care about the Node version I have installed locally. I don't want to care about the Python version, right? I don't want to care about a proper local configuration. I just want things to work out. And I want to do all this in a consistent way and as many times as I need it. I want to be able to continue developing or doing whatever I need to do while tests are running. And one of the more important things, I believe, in all this approach, and if you take something from this talk, take this with you, is that putting everything in a workflow that uses Docker improves knowledge sharing. So if you want to work with more people, with different teams, when you put everything in Docker and use Docker Compose files, basically you're documenting how to run and use your application. And the top of the tip of the cake, what makes everything look nicer is that if you know how to run tests in a standard way, you also see how your application works. So this is great for people who want to contribute to your repository or people who want to join your team, like onboarding new hires. So the first thing would be to actually put our web application. This is like a typical Hello World example, right? Because this is a very simple application, but the idea is to put the application inside Docker. So we follow best practices, like for example, using and putting the files that contain all dependencies at the beginning. Then we do an npm install, and at the end of the Docker file, we actually add the application to the container, to the Docker image, sorry. So we have these layers well built. We do the same thing with the tests. I'm using tests that were written in Python. So again, following the best practices, I copy first the files that declare all dependencies, I install the dependencies, and then I copy the rest of the code. An interesting thing here about this Docker file is the wait for grid file. So have you ever heard about this concept of wait for in Docker? If you haven't, the idea behind that is that when you have a container that is up and running, this doesn't really mean that the application inside that container is ready to receive requests. So normally a way to clarify and to have a proper way to establish dependencies is that you should not execute anything to that container unless you know that the service is ready. A way to do that is like widely used, this concept of wait for. In this case, when a Selenium grid is starting, it's putting up different things, like containers and all that. And then there is an endpoint that says if the grid is ready or not. what this script is doing, which is available in the demo repository, is basically pinging that endpoint and waiting for a response. When that response is positive, then it just follows and continues and executes the command that you can see there, pipm run tests. So this is also applicable for databases, for any type of service that you need to depend on. And you can put everything together in Docker Compose. To avoid duplicating content, we're using this feature that we have now in Docker Compose, which is the include. So we have this Docker Compose file that basically declares how to start up a grid in a nice way. And then we have the to-do app with the Docker file, with the command to start everything, and so on. We also have the Python tests, and we try to follow the rule to avoid hard coding things in the code, because obviously the test should work in any type of environment. It should work anywhere where we want to execute them. So in this case, we're telling the tests where the application under test is living. In this case, it's called to-do app on the port 3000. And we are also telling the tests where Selenium Grid is living, which is in that endpoint. Now that we have everything inside Docker, it's much more easier, right? Because we can start everything and tear down everything with just a single command, and in the middle, we're running tests. We have consistency in the process across different members of the team and different teams, and also we have consistency in the commands we're using to put everything in our pipeline. We're going to have fast feedback because we're running everything before actually pushing to the upstream repository, and that is how we can improve the development workflow. In this case, we're executing all these tests, 9 in total, in 20 seconds. So bringing everything up and down and executing tests in 20 seconds. So that's pretty good. But obviously, this depends, right? This depends on how many tests you have. And that brings us to a different conversation, which is testing strategies, like what to test and when. And I would be happy to talk about that. Like, if you want to talk about that after the talk, I will be happy to talk about as well. So what we have seen until now is that this approach is going to help us to have consistency between environments and between team members and teams. This is leaving us almost ready, or I would say ready, to a DevOps workflow. And the main thing here is that we want to avoid these scenarios where things work locally and then we run the pipeline and things fail over there. We want to avoid that. And the main point here is that we just want to use the same commands, the same setup everywhere. One of the benefits of running UI tests in continuous integration is obviously the fast feedback, right? And we want to avoid these differences between different environments. Something that is super important is that debugging is simplified because we're using, again, I'm reiterating myself, but we're using the same commands either on the pipeline or locally. And again, one of the things I mentioned already is that, in my opinion, one of the most important things is that we're sharing knowledge across different teams and across team members. So if someone has to debug this, they can just use the standard command to run tests and to build images. So we can put basically the same command in an example workflow file here in GitHub. The only difference that we have here regarding the previous workflow is that we're using this flag in Docker Compose that is called abort on container exit. And the idea is that when you start your web application, it's up. And when you start the Selenium Grid, everything is up. But they don't tear down themselves because they're just always waiting for requests to come in. The only thing that tears down itself is the group of tests that you're running, right? Because they start, they get executed, and they're teared down. So the idea of this flag is that when this container stops itself and tears down, then the whole Docker stack brings itself down. So here, we're going to see the same example, but now working in the CI/CD. One nice thing that we can see here is that when we start putting everything together in CI, we easily see how time starts to add up. Like a workflow that we saw that locally took around 20 seconds, now in the pipeline it could take easily, I don't know, 2.5, 3 minutes, which is still okay, but when you start adding more and more tests, it gets a bit longer, right? And one of the key things that we have to invest time with CI pipelines is that we need to tune them, especially around caching. So if we build something in the CI, we have to either maybe use the different features that GitHub Actions offer you, like caching the file system or pushing the build image somewhere in between steps, so you can find a different approach that works for your context. But it's super important to realize that this is something that we still have to figure out, how to do proper caching, so the time we are spending for testing is still low. So up to this point, I've been sharing how all these features in Docker Selenium helps the developer workflow and using a very good approach that makes us ready for a DevOps workflow. So now let's talk about some extra features that these Docker images have. The first one is video recording. The conventional setup of a Selenium grid is to reuse the same container for different tests. Not concurrently, but one after the other one. And what happens sometimes is that it's really hard to record video when you're using that approach. So what we have done is we have developed something we call a dynamic grid. And what we do here is that we mount the Docker sock to the container, so the Selenium Grid application, which is implemented in Java, talks directly to the Docker API. And what we end up doing is that every time a test comes to the grid, we identify what browser we want to use, and then we spin a container with that browser. We start recording the video, and then we also record the logs, and we dump everything to a mounted directory. Let me show you the configuration file for the Selenium Grid. Basically, what we do here is that we have a set of Docker images, and we map them to a configuration that Grid understands. For example, the first one is the Docker image that contains the Firefox browser, and we're going to tell the Grid that this image can be used for the Firefox browser and under the platform Linux. Same thing for other ones. And if you want to extend yourself a bit, you can also add things like the browser version, because we have different versions of the browser in these Docker images. Something that is interesting a bit below is the URL. And that URL is the URL that the Selenium Grid is going to use to talk to the Docker daemon, to the Docker API. If you remember, in the previous slide, I was showing you that we were mounting the Docker sock. And what happens very often is that when you mount something to the Docker container, it ends up mounted as root, especially in Linux environments. So what happens is that for security reasons, we don't run this Java binary inside the container as root, but we run it with some user that is actually having less privileges. And then, since this user has less privileges, it cannot access a socket that was mounted with root. So what we do internally is that we use socket to put this socket in a port, and then that's how we talk to the Docker daemon. In the end, we have the video image that is used to record using FFmpeg, the VNC stream that we can see inside the container. And then we have the workflow, if you want to put this into GitHub Actions. Interesting things that also you have to create the assets directory and give proper permissions and ownership to this asset directory, because when you mount something in the container, then it's going to be mounted as root when you have Linux as a host. And in the end, like, you execute all tests, videos get recorded, and at the end, you are going to have all the assets, and you can upload them to this GitHub Action upload artifacts. So let's see how that looks. This video is going to be a bit faster. I have improved the speed, so we don't actually have to wait for all that. In the end, what is happening here is that we're going to have more features that is going to give us more visibility into what is happening into the tests, like video, logs, and all that. But then it's just going to take longer because Grid is now pulling images from Docker Hub. When it starts, it's going to take longer because every time a test is executed, a new container is started, video is recorded, logs are collected, and then dumped into a shared and mounted directory. So when you have more features, normally this requires more tuning, right? And that's the thing with more features. So we have this out there, but then you have to figure out how to do proper mounting, how to do proper caching, maybe pull the images before, and that's something that we recommend to all the users that we have. So then you download things, and then you can just check the different videos. In this case, because a test failed, you can debug that, you can check the logs, and so on. Yeah. One key question that we get asked very often in GitHub issues, in the Slack workspace that we have for Selenium is, okay, so what about Windows? What about Mac OS? What about Safari? What do we do with that? And they are right, because cross-platform and cross-browser testing is essential for providing a positive user experience. And if you want to reach a wider audience, then, ideally, before a release, you should test in a different and wider range of browsers and platforms. One of the key things here is that you need to understand what's the market share you have in your own application and what are the demographics. A simple example of that is here in the United States, Safari has around the 30% of the market. So if you want to release something to a wider audience, you should figure out how to test in Safari. And then, for example, accessibility testing. Depending on where you are, on where your application is used, there are different regulations. And maybe you need to check that your application actually complies to the local regulation in terms of accessibility. So different operating systems have different mechanisms to provide those features. So if that's important for you, for your application, maybe you need to figure out. That's why we have implemented an extra feature in Docker Selenium that allows you to connect this container to a cloud vendor. It could be Sauce Labs, it could be something else. Here's an example. We have the same configuration that we had before, and then we have this section that is called a relay. Relay because it basically takes all the commands and just forwards them to somewhere in the cloud. In this case, we're going to put the URL where this cloud lives, and we're going to put this configuration. Here, we're saying we're going to have maximum 10 instances or 10 concurrent sessions of Safari on Mac OS 13, which is Mac OS Ventura, I think. So we're using the same configuration we had before, but we're just switching the configuration file for the grid. Quick video, basically it's the same idea as before, but now we're changing in our tests, we're adding Safari together to the Chrome, Edge, and Firefox execution. It looks very similar, so we provide a similar experience that you were having locally, but now in the cloud. And this is something that is helping people to actually extend their browser coverage, offload what they cannot support locally, and sometimes people want to also try mobile testing. So this is something that people in open source have been asking, and we provided a way to connect both worlds in a simple way. A couple of more features that we have in this project is a Helm chart that, before we had some Kubernetes files that you could use to actually deploy, but they were kind of handcrafted, they were not ideal in many cases. So it's really cool to have a wide community because the community came together asking for a Helm chart, and some people came together and proposed it and sent a pull request with the Helm chart. So we can now do proper orchestration now in Kubernetes. We can actually customize all this, scale them up, and I think around 6 months ago, we got a contribution again from the community using Kida. If you're not familiar with that, it's a project that is like a plugin to different Helm charts in Kubernetes. And in this case, this is pretty cool because what happens is if you want to scale up testing, like run, 100 tests concurrently or something like that, and you have your Kubernetes cluster, the question is always, how do I know how many nodes I have to have running? How many browsers I need to have running? So what this plugin is doing is checking on the queue and saying, okay, I have 100 tests waiting to be executed, X amount for Chrome, X amount for Firefox, X amount for Edge, and then it uses that information to start booting up pods with those containers. And when the test has finished it, when the test has executed completely, the Selenium Grid has a flag to say, okay, this test is completed, I will shut myself down, which ends up triggering the feature we have in Supervisor inside the container to shut the container down, and then the pod shuts down itself. So it's like a kind of a dynamic grid, but in Kubernetes. So it grows and shrinks based on load. We also have observability via OpenTelemetry, which is pretty nice because you can plug your already existing monitoring infrastructure to understand better what is going on in your tests. So to start wrapping up, sorry, we're going to talk about some nice things that have been happening around Docker Selenium. So this is a project that started 9 years ago that basically came from the community and is nowadays a sponsored project by Docker. And we have around 7,000 stars in GitHub, which is a decent amount. What I wanted to show basically here with this graph is that it's not a project that became really, really popular one day and then it just doesn't grow anymore. It's basically a constant evolution over the years, like very, very consistent over the years, linear evolution, I would say. This tool, this project was actually shown here in DockerCon, at DockerCon in 2017, briefly for about 15 minutes. And basically, when it was shown here, this project had maybe half of the features that today it has. And the proof that we're continuously evolving with the insights of open source and collaboration from different industries is that today we're working on the set of Docker images that support different architectures. You know, with Apple having the M1, with the new ARM architecture, then these conventional images don't work because most of these binaries are built for x86, and then you need actually the binaries for the proper architecture to run tests. So we're now starting there, and it has been a big challenge because, you know, for example, it's not easy to find, no, it's impossible. There is not a binary out there for Google Chrome that runs on this architecture under Linux. So the option that we have nowadays is to use Chromium, which is not ideal because actually that's not the browser your users use, right? So that's a challenge over there. In addition to that, you cannot find a Chrome driver built by Google that actually runs also under Linux with this architecture. Same story for Edge. So basically, we're relying on the community for people who are spending time to build these things, and we use them to pack them in Docker images. Together with that, finding builders that are free to build these images is also challenging. I just checked yesterday that GitHub announced that they're now offering M1 builders, so we're going to try that, but it has also been a challenge to find a place where to build these images properly. And the point here is that, you know, all these changes in the project, all this evolution is coming because it's an open source project. And I strongly believe that open source drives innovation. Community input through GitHub issues, Slack conversations, you know, they're sharing all these things. And also something that has been shared lately is the complexity of the test environments and the tests they're using. This changes the technology we're using and how we're using it. But more than that, it also changes what we're doing conceptually. You know, one of the things is that the innovation that we have here in open source and the information we gather from the industry, they're just going together, collaborating to improve the developer workflow. So there was a GitLab developer survey where we saw that 47 of the teams were reporting that they were fully automated, but they were using between 6 and 10 tools when they were doing CI/CD. And today we saw a clear message in the keynote here at DockerCon that we want to improve the workflow for developers, and we heard things about Docker build and about Docker debug, really, really cool things that were interesting. But something I was still missing is, what about testing, right? Like, what are we going to do with testing? But I think that the most clear message during the keynote today was, it's not about local or cloud. It's about local and cloud. And that's why what we're seeing in the industry and in open source is that people are spending time to put all their tests and send them nearby the infrastructure. Because the idea is that when you have a complex test environment and you're mixing it up with scaling up testing, then you're spending a lot of time to maintain that environment. So there is a trend in the industry to send this test code in a Docker container somewhere else to be executed. And the idea is that you want to reduce latency and you want to let someone else handle that execution while you can repurpose locally what you have in your resources, right? And this simplifies testing at scale because I need to manage and maintain fewer tools. So the idea is that you're going to have like less load, less latency, and if you're interested, check the link for orchestration solution that Sauce Labs provides. So to start recapping, to conclude, all this developer workflow improvement with Docker Selenium is bringing us less context switching. We're using resources in a better way because we're running tests in parallel. We are not getting stopped by the execution of these tests. And super important, again, knowledge is being shared across teams, across members, and the onboarding of new hires is much more easier. With all that, we're having an environment, a solution that is leaving us DevOps ready. And with that, I just want to conclude and thank you all for being here. I am Diego, and if you want to reach out to me, that's my LinkedIn user, and that's my, what it used to be, Twitter user. Thank you for being here. Enjoy the conference, and see you next time. I'm here for your questions. Thank you.
Do we have any questions? I have an open mic here if you'd like to ask Diego any questions.
Yeah, so there is another microphone here if you have questions. I'm going to put the headphones in case you want to ask something. I'm here all ears for you.
Okay, then if we could go ahead and do a round of applause for Diego again. Thank you very much.
Thank you.